February the 15th, 2026. Guys, we've got an incoming comet, and we got to pay attention to this. I know there's a lot of young school comet YouTubers out there, but if you're not old school, I just can't help it. Age has a lot to do with wisdom. Sorry about that, but I was the one that told them Iceland was not going to hit the sun. It was going to scatter into a million pieces. That went against every scientist that they had, guys, every predictor and everything. Still, these young guys are doing a good job, but they got a lot to learn. C2026A1, called MAPS, formerly known by its temporary designation CAC 4721, is a Cruet sun-grazer comet discovered January 13, 2026, from the AMAX-1 observatory in the Atacama Desert. Now, if you look over the right, you come up a few days, February the 17th, from January the 13th, and James Webb Telescope got this image. Very bright comet. Let me enlarge that just a moment. Now, it was processed by Melina Trevino, image credit NASA, European Space Agency, CSA, James Webb ST. That's a James Webb Telescope mirror. I guess Qixing Jiang had something to do with the processing, and it has been processed, you can tell. And you dim down the back sometimes, the background, things like that. I've done it to get a better look at this comet. But I got news for them. This is not a sun grazer. They made a sad mistake. The sun grazers are smaller. They're saying this is the largest one they've ever seen, and because they've seen it further out than any other sun grazer. This is a large sun diver. They're incorrect about it. I'm going to correct it for you. And this thing is only about 6 weeks away from impact. It says on April 4th, 2026, it will pass about 99 miles from the surface of the sun. Guys, I don't know where these astronomers got their numbers. We're going to look at the real Jet Propulsion Laboratory numbers, the same way I did with ISON. It says it will pass about 99,000 miles from the surface of the sun. They couldn't be more wrong. When near the sun, a forward scattering of light could make the comet very much brighter, but hard to see against the glare of the sun. How bright the comet will get is largely unknown, as the comet may not survive the perihelion approach. That's true. This thing is not going to go around the comet. It is not a sun grazer. It's a sun diver. And it's the largest sun grazer, period, that they've ever seen. But this is not one. It's probably the largest sun diver that we have in any recorded history anywhere, even in ancient history. Now here in the observational history, remember I said it was first discovered from the Atacama Desert, and this is Elaine Murray and George Adard on January 17th, C21A1, right there in the center. And it says the object, again, was discovered by the AMAX Observatory at San Pedro de Atacama, using 28 millimeter 11-inch scope. Guys, it was discovered at a distance, let me pull this down, of 2.056 AU and our 191 million miles. Again, this was a few weeks before James Webb turned after seeing this image at a magnitude of 20. It turned, and by the time it got a good look at it, it was down to a magnitude 14. The lower the number, the brighter the object, and that a lot of times at this distance, before the sun really reacts to it, gives us an idea of the size. They're saying it making it the furthest sun grazer ever discovered. That's because it's the largest, but it's not a sun grazer. Surpassing the record previously held by Comet Akiyaseki, allowing a lead time of observations for 81 days before perihelion. The comet was a 17.8 magnitude at the moment of discovery. The earliest pre-discovery back in December 25th, they saw a small dot. It was about a magnitude 20, and it's gone down to a 17.8 by the Atacama Observatory with the 10-inch telescopes. Let's see. And now the apparent magnitude over on the right, it should be over here, I think is down to around a 14. Let's see if it's listed here. If not, it will be on the JPL map. Anyway, I don't see it there. But notice right here, perihelion. We're going to look at that on the map. That's the closest approach to the sun. Helium is the furthest approach. But this number 0.0057 AU is incorrect. That's not what the JPL is showing us at all. This is coming from the people, I guess, running the telescopes. And again, the numbers don't lie when you come to the JPL and looking at the orbital parameters. Yeah, here it is at the bottom, apparent magnitude 14.5, mid-February, which is exactly today. C26A1 is a Cruitz group comet belonging to the PE subgroup, a subgroup of the Cruitz sun grazers closely associated with subgroup 1, which all fragmented from the Great Comet of 1106. Other bright members of the subgroup include the Great Comet of 1843, C1963 R1. It will pass through the solar corona, listen, through the corona, that's like the outer globe is what they're saying, and reach perihelion on April 4th, 2026, when it will be about 0.00571 AU from the center of the sun. Now that's important. When they measure distances in orbital mechanics, guys, say the distance from the Earth to the sun, it's from the center of the Earth to the center of the sun, or the center of Mars to the center of Earth. Wherever the measurements, or the moon, comes from the center. Remember that. Again, about 1,600 kilometers from the surface of the sun. No way. Wait till you see it. With a short observation of 20 days, the comet's inbound orbital period calculated at epoch 1800, which is before entering the planetary region of the solar system, where we're at now, suggests it came to perihelion last around 1,700 years ago. Now, what they do, let me go back up here. They'll use data arc spans, and what that does is they'll only have a short arc, but that slight bend that they see from the first time they see it, for this one had 20 days of observation, to the last section of that arc, they will just take our computers and go backwards in time with that arc, and then go forward in time with that arc. And that is called the data arc span. Now, this is our JPL model from the Jet Propulsion Laboratory, and we're going to come right back up to it, but first I want to show you a little bit of the numbers. Let me scroll this down. And guys, this is where they break it down to the infinite. Man, I'm talking about, if you can get this math, you dig this math out, you're going to see where it's going to go. Again, 20-day arc span, right there, you see that? That's how many days. First orbit used was 2016. This year on January 13th. Okay, the last orbit in that span was February the 2nd. Anyway, right here's the key. A is aphelion, that's the furthest point from the sun, and Q is the perihelion distance. See that? That's the closest approach. And you just trace over here, and it'll give you the uncertainty is 1 sigma. But here's the distance, 5.7867 E, and technically it's a little e, minus 5. That minus is key. Now, when we do the math on that, which we're about to do, you're going to see a big difference than 160,000 kilometers above the surface. And you can take any of these numbers, guys. Go to unitconverters.net, type in astronomical unit to mile. 1 astronomical unit, again, 92 million miles, 93 million, excuse me. But I typed in exactly what JPL is showing us right there. See that? 5.786 little e dash 5. That's really how it's written out. That is 5,379 miles, not 160,000 kilometers. Do you realize what that means, guys? Now, the radius of the sun from the center to the surface is 435,000 miles. That's halfway through the sun. So you've got 870,000 miles approximately all the way across the sun. 864, I think, is technically. But they're saying radii is 435,000 miles to the center. Now, what does that tell you about 5,379 miles from the center when it is 435,000 mile radii from the center to the surface? That means this thing is diving through the sun, nowhere near 160,000 miles above it. Again, if you want to take these numbers and do a screenshot on it, you can go back to the map, which we're going to look at. You'll get the same numbers I'm getting. This is going to be an impact of a large object into our sun, probably the largest we have ever seen. Maybe anyone's ever seen. But the last orbit didn't bring it this close on the 1700 years, but the orbit changes as it goes out. It's affected by gravity, and after 1700 years, it's never going to come back in the same location. But guys, we've got a sun diver, not a sun grazer. Now let's take a look at the model itself, guys. Here's our solar system. Let me turn it up to what's called the ecliptic. It's pretty close until you get closer, and you'll see that they're not really in the same orbit, but very close. Now, see 2026 A1 is below us. It's rising very quickly. And I've got this pretty close to an Earth-facing situation. Let me put it straight in right there. Here's the Earth in the blue orbit. And let's tilt this back up. Again, a very steep orbit coming from below us right here. Now, up at the top, you can set this at 1 day, 1 hour, or many days, months, whatever. Right now, I'm going to leave it on 1 day, and we're going to get very close to the sun with that, and then we're going to drop it into the hours and look at the data coming from that, okay? Here we go, 1 day at a time, forward. Notice your timestamp. We went now from the 15th to February 21st. Each click is a day. Now, I've got it up to the day of impact on April the 4th, right? And it's here. If I step it forward 1 more day, you're going to see it, because it's traveling so fast, go and come out on the outer orbit. Watch this. That doesn't give us quite a good measurement, but if you're paying attention to this map at all, you already know where I'm going. Let's go back to the 4th on the day of impact. Let's switch this to hours right there. Now we can step forward in very close increments. Let's get up here. Again, notice it's staying on the 4th. This is all happening in 1 day. We turn this. You see that path through the sun? You think that's 160 kilometers above the surface? It's not even in the corona. Look at that. And when you center this thing up like that, look how, like I said, 5,000 miles from the center. See that arc right there, guys? Look at that. Now let's go forward. There. Let's see. That 1 hour, would technically have gone through the sun and coming out right here. See that? Yeah, it's not coming out anywhere. Now, let's go back 1 notch, or backwards 1 notch, to right before it enters. And our closest numbers, guys, again, do not match what we're seeing. Let's go. What we're doing here is it's showing 7.9 E-3AU, but that is because we're not getting, it won't go below an hour here. I can't go to minutes, because when we go through here, you'll see a different one. But what is happening at when it's closest to the sun right here? Now, again, you're seeing 7.99 E-3AU. But if you go back to the map I just showed you, remember, it was 5.7867 little e-5. That's what I put into the AU, astronomical units to miles. And that is 5,379 miles from the center. It's unreal. Entering here, coming from under the Earth, or under the ecliptic of the planets, and 1 hour later, supposedly will be on the outside of this orbit. But in the center, at its very perihelion, according to the JBL orbital mechanics, 5.7867 E minus 5 is 5,379 miles. Check it out, guys. Let me go back there and I'll show you real quick. So I'm going to go back through those 2 numbers just so you'll know. So if somebody, one of these young bucks out here that think they know something, reading from the astronomers' information, you need to look at the JPL orbital mechanic data. And again, Q is perihelium. See that? See what this says? 5.7867 E minus 5. When they got that minus on them, guys, you better pay attention. And that is astronomical units, AU, okay? Now we'll go back to the chart. Just maybe you need to show this to somebody. And this is the number again as it's diving through the sun right there. That's as close to the center of the object. Again, 5.7867 E-5 or minus 5. That is 5,379.073 miles. That is basically the center of the sun. Think about it. Again, your radius halfway from the center, halfway through the sun, from the surface to the center, is 435,000 miles. How is that 160,000 kilometers above the surface of the sun? I don't get it, but guys, if you remember my first, I've had one channel taken down, maybe 400,000 subs, 20 million plus views, a lot of videos. But there was one before that called Mr. Comet Watch. Remember that? That's how I got my name. That's why, because I know what I'm doing when we come to these things. By the way, the only decent image I've seen of what's really inside Atlas is the one that I have from the thermal unit showing the craft inside that. But scientists are very hesitant, including the ones you watch on TV. They're very hesitant. Not one of all the people that talk about it have shown that image, and I've sent it to every one of them. It just doesn't fit their narrative. So be careful. Again, all young buck astronomers are not for the truth. They're for the media perceptive, what they want you to see, right? But there's a way to find out for yourself, and you just saw it. Anyway, we're watching it, guys. You got to watch it in Florida. Tornadoes are ripping through that area. The first one I saw was very just north of Panama City, heading up towards Mariana, and I haven't looked back at it in about an hour. I've been looking at this map. But Florida, you're going to get that sweeping motion through there. The low pressure is over Mississippi now, so there's a secondary rain pattern forming behind that. Doesn't look as strong as far as nasty weather, but definitely it's still raining here from that secondary surge from the low pressure system. I'm looking at it raining out of my window. Also have a very good update on what's going on in Tucson. That'll be up later, guys. Anyway, we have a comet that's going to strike the sun in about just over 6 weeks. What will happen? Again, I always think about the fourth angel pouring a vial out upon the sun. I don't think we've ever seen one this large hit it. We don't know what the reaction will be. Anyway, we're watching it, and we're going to watch it up until April the 4th. And we'll be watching it through the satellites and all the other information coming out, because I know how to do it. It's a heads up, guys. Be safe.